Nope. All right, so hello everyone. My name is John P. Doran, and today I'm excited to talk to you about how we can use games to learn in this complex world that we all share. I do apologize that I'm not standing up. A couple weeks ago I fell on my bike and I'm told to rest. So I apologize in advance, but here we go. The core idea of what we're talking about today is pretty simple. As we've already heard today from both Professor Enfield as well as James Casey, games aren't just for entertainment. And they're living, they're dynamic systems. And when we start to look at them in that way, games have become powerful tools that we can use to help us to understand and navigate the world that we're in that's getting more and more complex every single year. So, hey, there's my slide. Yay. All right, so hey, that's me. As I mentioned before, my name is John P. Doran, and I am a technical designer. A technical designer is a game or level designer by training that is known for their technical skills. And I've actually become more and more technical as time has gone on. I actually went to school to make games. I got my Bachelor's of Science in Game Design before eventually transitioning to doing a Master's in Computer Science. And currently, I'm doing my PhD here at Mason in the States for the Computational Social Science program. But I went to school for games, and then I went to the industry to make games. I worked on various projects in many different teams. I worked as a lead UI programmer at Interceptor Entertainment, but probably the most famous game that I worked on was Star Wars 1313 when I worked at LucasArts. Since then, I have transitioned into education, and I've had the privilege of being able to speak or to teach in the US and Singapore, as well as right here in Korea. And currently I teach most of the programming classes as well as other game design classes within the major here. But on the weekends, I write books. And I've written over 15 books on game development, building games using just C and C++ from scratch to working in engines such as Unreal as well as Unity. And so helping people to make games is my passion. And hopefully today I'll be able to talk to you about making games as well. Click, there we go. Now, before we get started, I wanted to talk a little bit. Am I going too fast? Is that okay? We're good? Okay. Just making sure. Good. So before we get started, I did want to talk a little bit about what I mean when I'm saying complex or complexity, because I'm going to be mentioning that a lot. And to start off with that, though, I do want to talk about what makes something simple and also what makes something complicated, because oftentimes we're confused between the different reasons. So I would say something like baking a cake is simple to do, right? You follow a recipe, there's clear steps, there's clear ingredients that need to be done, and assuming that you stick to that recipe, you'll pretty much get the same result every time that you do it. Now, skill does help, right? If you're skilled at baking, your cake could be better, sure, but even a beginner can succeed because the rules are stable and they are predictable. And so the context doesn't change much each time that you do it, right? Your oven may run a little hot, or different areas may be hotter than another, but that's not going to fundamentally rewrite the recipe. Meanwhile, something like a rocket, or sending a rocket to the moon, is something that I would consider to be complicated, right? We understand the physics that's involved with it. We can take it apart. That we understand the engineering that can be used for it, but putting all of that stuff together requires us to have precision, to have coordination, as well as a huge amount of specialized expertise, right? There's more uncertainty compared to building a cake, and there is more that can go wrong, things like bad weather, the atmospheric conditions, the launch timing, so on and so forth. Complicated tasks are difficult, but they do remain predictable if you understand all of the pieces. But however, right, something like raising a child is complex. I don't know if we have any parents here. I have a 5-year-old daughter. She is a ball of wonderfulness, but there is no recipe for working with your child. There's no checklist that guarantees success, right? Now, of course, every child is different, and every context is different. And what works beautifully one day can the next day end in a failure, right? But now, of course, expertise helps, experience helps, but neither guarantees the outcome that's entailed. Complexity means that our system is changing while we're trying to work with it. So to kind of sum this up, right, complex systems can be hard, but they remain predictable, and they can be broken apart, like repairing a clock or assembling furniture at IKEA, right? Whereas complex systems are full of all of these different relationships and interactions that happen, like classroom dynamics, or wicked problems that exist, like climate change, right? We can't solve a complex system just by breaking it into parts, because those parts constantly influence each other. And this is the world that we live in, and that our students live in, right? Our students experience this complex world every day, oftentimes in ways that they don't realize it, right? Every day, students interact with systems. Now, when I say systems, I don't mean anything complicated or theoretical. I just mean the everyday patterns and the cause and effect chains that we already see all around them. Things like social systems, right? Who sits with who at lunch or during this conference? How conflict spreads over time, and how norms form within a group, right? We already know that if someone has an argument between two kids, that can completely change the mood of your whole classroom. There are digital systems that we also interface with, right? Apps recommend videos to us, or they recommend content to us in specific ways. Likewise, trends spread, and one post can go viral for various different reasons. Students see firsthand how algorithms push content to them and how their actions make what they see happen. Students live inside of these systems daily, so understanding complexity can help them to make sense of their daily lives. So continuing with that though, schools don't necessarily bring that up, right? Much of formal education still treats learning as if the world is moving in a straight line, right? We have chapter 1, then chapter 2, and we oftentimes talk about these clean, step-by-step procedures that we have to do. And we oftentimes measure success by whether or not students can repeat those steps correctly. But real life isn't linear, right? We've just talked about how it's full of different surprises. A minor decision that you make can trigger a major consequence in another. Has anyone here programmers or write code? Yeah. Well, you might know, right, if you fix one problem in your code, sometimes you'll find that there's even more, right? Likewise, a small policy change that's made can affect your community in many different ways. This concept is what we call non-linearity, right? This idea that the cause and the effect are not proportional and they're not predictable. And interestingly, this happens to be the behavior that games simulate quite well, right? If you're doing a city builder, a game where you're building a city, placing a different building can trigger various cascading changes. Likewise, if you're doing a deck builder like Balatro, buying a single card can completely shift your strategy for the rest of the game. And that brings us to this bigger shift that we're seeing happening in education right now. We've talked previously today, right, about how AI has become more and more capable, right? The skills that we used to prioritize, things like memorizing facts, knowing those exact procedures, are increasingly things that we're seeing that machines can handle for us. Now that doesn't mean that our work as educators matters less. But it does mean that what we are doing, what our purpose of education is going to be evolving, right? Instead of asking, what facts can my students recall, we have to ask what kinds of thinking will matter in this world where information is abundant and easy to get and tasks can be done easily. They can be automated. And one answer rises to the top for me: systems thinking. Right? Understanding how different parts of a situation connect to each other. Recognizing the different feedback loops that exist. Anticipating what small changes you can do that can cascade throughout those larger systems. This kind of thinking matters everywhere, from economics to climate science to social media and everyday problem solving. It's how students learn to see the bigger picture and respond thoughtfully within unpredictable situations. And again, games give us that ability to do this, and they've been quietly teaching this concept to us for decades. When we think about games, it's easy to think about the surface features. Things like their graphics, the story, the characters, so on and so forth. Now, this can definitely be important, but underneath all of that is a system, a set of rules, variables, and feedback loops that govern how the game behaves. Every time our player acts, different things will happen and the system will respond. Your health will go down, resources will go up, enemies get spawned, the world state changes. Players feel those changes moment to moment, even if they never use the word system dynamics to describe it. This makes games powerful learning systems, as we've learned previously today, right? Players don't just consume content like videos or books and so on and so forth, but they interact with it in a way that the environment will respond to them. They try things, they see what happens, they adjust, and they try again. And because it's a game, there's no penalty. It's a safe space for you to make those changes. And a lot of those properties that we see in complex systems, feedback, nonlinearity, and emergence, are things that we already see in well-designed games. And so the question becomes, how can we as educators leverage this, both inside as well as beyond formal education? I'm going to skip that and dive right into the examples. This here is the game City Skylines, a popular city building game. Now, I know that there's a sequel, but I haven't played it. I'm assuming they have this, but better safe than sorry. In the game, players manage a city, and they manage things like roads, the zoning that's used, the utilities in the area, as well as the services that are provided. And one of the most common, memorable learning experiences that people have when playing the game is through its traffic, their traffic simulation in the game. You add one road to clear up a certain area, you fix the jam in one neighborhood, then all of a sudden you've shifted that congestion to the highway, right? And without any formal lecture, players are discovering these core ideas and from systems thinking and from urban planning, They see that local fixes can have global consequences. They recognize that traffic patterns are emergent, right? They arise from the interactions between many individual agents that can be modeled. Things like the cars, the trucks, the pedestrians, and not just from one central control. Likewise, they also experience feedback loops, right? For example, traffic delays may reduce happiness, which affects population growth, or business activity, which in turn changes traffic again. That insight is precisely what we want for learners to develop in many other domains. And games provide a sandbox for that exploration. Another game, Frostpunk. Anyone ever play that? No? Yeah, yeah. There we go. Yeah. This is another powerful example here. Frostpunk is a city survival game where you're leading a group of people struggling to survive in a frozen world. Here, the system is not just mechanical, but it's also ethical and it's based on social norms. Players make decisions about things like how much people can work, whether children can work, public order, as well as other healthcare issues. Each choice that they make has consequences. Pushing people too hard may increase production in the short term, but can damage the morale and trust that people have in you, which can undermine the society in the long run. In other words, Frostpunk simulates what happens when human systems are under intense stress. Players confront trade-offs, they don't have easy answers, and so they learn how maximizing one variable, like production, can break others, like our hope and our stability. Last but not least, Vampire Survivors. I know, we're going a whole other point here. Anyone play that? No. Yeah, there we go. We got some more people here. This is for a completely different flavor of complexity. On the surface, this is a very simple game. You move your character, and the character will automatically fire weapons on their own. The only thing you do is pick where you are. But just beneath that simplicity, there's a surprisingly rich web of different interactions between the different items, upgrades, and synergies that exist in the game, as well as the enemy patterns that go over time. Players learn very quickly that power doesn't come from a single upgrade in isolation. It comes from how all of your previous choices combine together. Some pairings of upgrades create compounding exponential effects, where you get tiny early decisions exploding into a bunch of different things that have massive power later on. Other upgrades seem strong, but they collapse as soon as you see the enemy's behavior change. These small choices turn to big outcomes. This is a perfect example of emergent gameplay, right? Simple layers layered together, which create deep and unexpected behavior. We see this oftentimes in games and in game development. Likewise, we use that whole feedback that we talked about earlier, right? You test a build, you observe what happens, you revise your choices, and you try again. That loop of hypnosis, hypothesis, test, revision is the core of experimental design. Sorry. All right. So this brings us to an important shift in regards to how we think about people learning. But before we get started with that, we do have to ask ourselves, what is our goal when we have students? What are we trying to get out of them? And what do we want students to do with their brains? So let's start with a framework that's been a bedrock for educators for decades. I think I broke it. There it is. All right, we have Bloom's taxonomy. Anyone see that before? Yeah, good. Seeing hands, that's good. Now, some of you, like I mentioned, probably seen it before. It is a framework for categorizing educational goals and you can think of it as kind of a ladder of goals for thinking. Now, this has been around for a long time, since 1956, but there's actually two different versions. The revised version that I have here was modified in 2001. And I like showing them side by side because they illustrate a shift that mirrors the theme of this talk. Right? The biggest change that we see here is instead of using nouns, we're using verbs. Having knowledge comes remembering. Having comprehension means understanding. Application becomes apply, and so on and so forth. But you'll also notice that at the very top, the goal has been changed. The final original version of being able to evaluate has shifted down a level. And at the very top, we have a new skill, creation. Right? Now the bottom of the ladder comes with remembering, which again is simply recalling facts. Likewise, the second, right, understanding, is where instead of just having that knowledge recall in your mind, you instead can explain and you can describe what's happening in your own words. Now, honestly, and this is, like Song previously mentioned, this is where most schooling stops, right? Or at least a lot of emphasis is placed on this area, right? Just being able to recall and comprehend what's there. But if we move above that, we have an application, taking what you know and using it in a new situation. Next, analyzing, right? And this is where things get interesting, where you're starting to look for patterns, relationships, and structures between what's going on. Step 5, evaluate. Right? You're comparing different ideas together. You're critiquing arguments that people have. You're assessing theories. And at the very top, creation. Create. Right? Which again, that idea is simple. Learners understand most deeply when they build, when they design, or when they generate something themselves. And that is what we're going to be building towards from now. So again, we've covered that level 1 and 2 are already done, or are typically done in school already, but we want to continue to move up these levels, right? Until we get all the way to the top. And so with that in mind, how do we jump to level 3, application? Well, simulations seem like a no-brainer, right? They let students experiment, they fail safely, and again, Jacob mentioned some examples from the previous talk. But with that in mind, let's see what happens when a complex simulation actually enters a classroom. So this was a study that was done from the University of Otago, and what they did is they took pharmacy students. And they had to learn how to properly dose this drug that exists called warfarin. And the way that drug works in the body is super complex, and it's not at all predictable, which makes it the perfect challenge for this type of learning. So here's the thing, though, right? They did not do this in a lab. They did it in a classroom, making use of a simulation, much like what we've talked about today. And doing this in a classroom, which again is a situation that I think probably seems familiar to a lot of you. And so over the 50 minutes of their class, again, this was hands-on, where the students didn't just read about the drug, they ran that simulation. Now the first time that they ran the project, they had to see what normally happens. What's the baseline behavior? But then they had to make a prediction of what would happen if a patient had a different genetic modifier and then predict what their effect was going to be. Then after that, they had to guess what would happen if a patient missed a dose or if something else was different in how they responded. And they had to keep making these educated guesses, and then they would be able to make changes and then see the results after running their own simulation. And the question that you might have is, does this learning work? Well, before doing this workshop, the students had a 45% grade in regards to their comprehension. But after doing this one workshop, their scores jumped up to 81%. A massive leap in understanding. Maybe not an A, but better than a 45, right? And simulations are effective for us because they allow us to take abstract concepts and create things that allow us to see how the drug is interacting in their body, and they can test ideas without having that risk. All right, but now let's head to the top of the pyramid. Let's head to creation, right? Where we're going from just being a student to being an inventor, where we take all those pieces of what we've learned, what we understand, and rearrange them into something completely new. A new idea, a new design, a new way to look at the world. Again, so what we're going to be doing is we're going to take a look at Hexacago Health Academy, where students, high school students, stopped being players and instead became designers. So this is a school that exists inside of Chicago. And they got a group of students together, high school students, that weren't just learning about public health issues like food deserts and community violence. They were challenged to take their knowledge and to create their own games to try and solve these complex issues. Moving on from that, when they were playing the game, there was an amazing amount of possibility for building an emotional connection, for making those abstract ideas that you've learned in class feel real. And you don't have to take my word for it, right? As you can see there, that was a quote from the research study where they talked about how one of the students said, that the act of actually playing and engaging with the problem created an aha moment for them. And that's wonderful. But the deep learning doesn't come from just playing, but also designing the games themselves. From going from being a passive learner to a deep observer. And so, designing the game unlocked a whole new level of learning to them. The act of designing forced them to work together, to think on their feet, and to truly understand the structure of the system that they were trying to model. And this went deep. It's a little hard to read here, but if you look at number 3 there, you'll see that they're saying that they've connected the legacy of slavery to the modern prison system. That's some serious analytical thinking there. And so that kind of leads me to those of you, now again, many of you are teachers, educators, and you might be thinking, my students aren't game developers, or I don't have that background. But it doesn't need to be the case. It doesn't have to be that. The Academy did come up with a 6-step process talking about how to do this. And the secret sauce that we have here is step 4, which is reskinning. All that means is take a game that you already know, something like Monopoly or Blue Marble here, or a popular commercial name like Holly Golly or so on and so forth, or a card game, and just changing the theme to fit your problem. They map their topic onto a particular game system that already exists, and then they iterate on that after playing it. And again, make it better, make it better. My whole mantra is playtesting plus iteration equals polish. And that is a brilliantly simple idea to make it so that game design is accessible to pretty much everyone. And with that in mind, right, we took this journey today, right? We talked about Bloom's taxonomy, we went to the potential of simulations, we went all the way to students creating their own games. So what's our takeaway? Well, again, when teaching, always start with the goal of aiming high and aim for creation at that top of that ladder, right? Secondly, simulations are a great tool, but do be realistic about what you'll be able to accomplish within your classrooms and the other constraints that you have. Lastly, or thirdly, think of games as more than just fun content delivery. right? Use them to see 21st century skills in action. And finally, and this is the most important one, do whatever you can to move your students from just being consumers to being creators, just like we heard earlier. Because truly, the act of building a system is the best way to understand it. All right, so hopefully I didn't go over. Hopefully I'm okay. But that is all that I have for today. So thank you very much for your time and your attention. I'd love to hear any questions, thoughts, examples, about your research, design practice, so on and so forth. My email's here, so feel free to send me an email or talk to me after this. But again, thank you so much. I'll talk to you later. Bye.
제 교대대로 열정적으로 강연에 임해주신 저희 존 도란 교수님께 다시 한번 박수 부탁드립니다. 감사합니다.